Okay, section 3.6, some more problems, and these are, again, applications of the chain rule. And number 14. And what we have here is this function y equals cosecant x plus the cotangent of x to the negative 1 power. So this is like u to the n. We'll just take the derivative of the outside function. The outside function is something to the negative 1, or like x to the negative 1, which is negative 1 times x to the negative 2. And that's our outside function, times the derivative of the inside function. So again, we take the derivative of the outside function, which would be negative 1 times something to the negative 2. This is like x to the negative 1. Times the derivative of the inside function. And I've underlined in orange the inside function. So this is the inside function. So we take the derivative of the outside function, leave the inside function alone, and then take the derivative of the inside function. So this is like the f prime of x, and this is like the g prime of x in our chain rule. And then we take the derivative of this. So again, we write the dx. As we talked about in class, this is a little bit easier way to kind of keep track of things. It's a few more steps because you have to do rewrites, but that's all right because it's a little safer, better safe than sorry. And the derivative of the cosecant is negative cosecant cotangent, and the derivative of the cotangent is negative cosecant squared. That's why you want to know these formulas by memory and well, so you don't have to take a lot of time looking them up. All right, and then what I did was I put this, since this was the negative 2, I put this in the bottom of the fraction, so I move this down here. So it goes down here as a positive 2. And I factored out a negative sign, and I multiplied that negative that I factored out times that negative, and it became positive. So I wrote this over here as cosecant cotangent plus cosecant squared. So again, we factored out the negative sign, and a negative times a negative is a positive, so that took care of those two. Or I could have multiplied out using the distributive property also. Put this in the bottom as a positive, and I've got this. Now here I've got a cosecant in both terms, so I can factor out the cosecant, and what's left is cotangent plus 1 cosecant. And then I wrote the bottom out, I expanded this out as cosecant x plus the cotangent of x times itself. That's a square. And then you notice that these are the same, but if you use the commutative property of addition, this is the same thing as one of these. In other words, cotangent plus secant, same thing as secant plus cotangent. So those become 1. So what's left is just this. Cosecant x plus the cotangent of x. Right down here. Okay? So I just have to be really careful. If you write your work neatly and organized, you won't have any problems. Okay? All right, hope that's clear. And if it is clear to you, remember it's clear because there's lots of space, it's neat, and it's organized. So keep that in mind when you're doing your homework, because you're going to go back, hopefully, and use this to review for any kind of assessment, so you want to be aware of that. Okay, let's take a look at number 16. And here's number 16. Now we have these two functions, x cubed, and then we got 2x minus 5 to the 4th. This is where we're going to apply the chain rule because we got something to the 4th, which is just not x. But in order to take the derivative of this, dy dx, we're going to have to use the product rule, so that's going to be the first times the derivative of the second. So the derivative of this is going to be like x to the 4th, or the derivative of something to the 4th power will be 4 times that something to the 3rd power times the derivative of the something. So this was the chain rule. So that was my inside. Okay? Plus the second, which is this, times the derivative of the first, and there's no chain rule there because that's just x, so it's going to be 3x squared. So I have to have one more step to take the derivative of this. So this is a rewrite. This is the same. And then the derivative of 2x minus 5 is just 2, so that goes there. And then all I did was put the 3x squared in front. So that's why we have this. Just put the 3x squared in front. And then I just multiplied out. Now I got a little closer because I was getting down to the bottom of my page, so I tried to get everything in one page, so I multiplied out. I still skipped a line though. I mean, so I still spaced it out. Not as much as I would like. So I multiplied 2 times 4 is 8, so I've got 8x cubed. and I've got my 2x minus 5 to the third, and I've got my 3x squared, 2x minus 5 to the fourth. And notice that I've got a common binomial factor of 2x minus 5. So I would factor out the least power, which is going to be 2x minus 5 to the third. Now when we're doing the product rule and the quotient rule, those lend themselves to situations where we can apply least powers, and that's one of the problems we did, or that's one of the review sheets we did in the summer, least powers. So now you're going to see how this comes into play. All right? So my least power, I have an x squared and an x cubed, x squared and x cubed, so the least power was x squared, so I take the x squared out, and I got a third power and a fourth power of 2x minus 5, so I take the third power out. So this is what I factor out. If I divide this out, or if I take an x squared out, that just leaves me with an x, so I've got 8x. And then if I divide this out, that just comes right out, so that just becomes 1. And I didn't write that out, but I will in another example. So this comes out. So all that's left in this first term, since I take the x squared out and the whole 2x minus 5 to the third power out, all that's left is 8x. And in the second term, I take an x squared out, so there's a 3, and I take 3 of these 2x minus 5s out, which leaves me with just one 2x minus 5. So this is after I factor this out. Now, I was kind of running out of room, so I kind of combine steps here. If I multiply this out, I get 3 times 2x is 6x. 3 times negative 5 is negative 15. So I have 6x minus 15, and so I can combine these. So this stays the same, this stays the same, but I'm going to combine this bracket and write it in this parentheses. So it's 8x plus 6x, 14x. And then just negative 15. And there was just a negative 15 there because all I could combine was the 8x and the 6x and got 14x, and then I had just the negative 15 up here. So again, everything in this parentheses eventually simplifies to be everything in this parentheses or this bracket to this parentheses, and these are the same. All right, so again, we're using least powers. Okay? So I hope all that is clear. And as always, if something in one of these bothers you, remember to ask in class. But I try to write out enough steps, so hopefully it's clear what we're doing. And your algebra should be good enough to follow it. But if you have any questions, please ask in class.